Welcome to this eLearn Security video training lesson on iOS network analysis. In this video we are going to see how to configure our host machine, the iOS simulator, and the actual device in order to sniff, intercept, and analyze all the traffic network generated by the device. Let's start with seeing how to set up a proxy in order to intercept all the device communications. This is very useful during our test since it allows us to understand how the applications work and what data it sends through the internet. Let's see how to configure the machine to intercept the traffic generated by the simulator. The first thing we need to set is a proxy server, which will intercept all the communications. We are going to use Burp Proxy to intercept the traffic, so let's run it and set the proxy configuration. Once Burp starts, let's move in the tab Proxy and then Options. Here we can see a list of listeners. In order to intercept the device traffic, we need to set a listener on our machine. Let's select the first one and click Edit. So let's bind the listener to the port 8080 and choose our machine IP address in the drop-down menu. 192.168.3.26. Now that the listener has been configured, make sure that the running checkbox is enabled. With the proxy server set up, the next step is to set the proxy on the simulator. Since the simulator itself doesn't allow us to set a proxy, we need to set it in the host machine. So let's open the system preference and click Network. In this view, let's select our network interface and click on Advanced. As we can see in the Proxies tab, we can set different configurations for this NIC. We are interested in Web Proxy and Secure Web Proxy. Let's click on the first one and then set on the right pane. Here we need to set the proxy server address, the one specified in Burp previously, so it will be 192.168.3.26, while here we have to set the port, which is 8080. The same configuration must be set on the Secure Web Proxy. With the configuration complete, we should now be able to intercept the simulator traffic. So all the traffic will pass through our proxy server, and we will be able to take action on the traffic such as inspect, edit, drop it, and much more. Let's open the simulator and then try to navigate the website www.elearnsecurity.com. As we can see, Burp intercepted the request. From this view, we can now choose to edit, drop, forward the request, or send it to other Burp tools. For now, let's just forward all the requests, and as we can see in the simulator, the page starts loading. So the proxy is working fine, but what happens if we try to load an HTTPS page? Let's try to open the address https www.google.com. As we can see, a warning appears on the phone screen and Burp doesn't intercept any message. This happens because the phone doesn't trust the certificate that Burp is providing. If we click on the details, we can see the writing "not trusted," and we can get more details about the certificate. We can see that the certificate comes from Portswigger, which is Burp, and that the common name value for this certificate is www.google.com. So let's accept and install the certificate and see what happens. As we can see, as soon as we accept the certificate, Burp intercepts the request. So let's forward it so we can continue. Now another warning appears. We can see that this time the common name is different. The previous certificate is valid for www.google.com, so every time this value changes, we need to accept the certificate. As you can imagine, this is not the best way to set our simulator, and we need to find a way to install one certificate that is valid for all sites. Otherwise, we are forced to accept lots of certificates. While on the actual device, we can simply download and install the root certificate authority certificate. For simulators, we have to install it by adding the certificate values in the TrustStor database. To do this, we can use a script that can be downloaded at the following address. It's a Python script that takes an input of a certificate and adds all the necessary entry in the simulated device. Before using it, we need to download the root CA certificate from Burp. Let's open Firefox and configure it to work through the proxy. So let's click Firefox, Preferences, enter in the Advanced tab, go to Network, then Settings, and enable the manual proxy configuration. Now that Firefox has been set, let's load the address https://www.google.com. This forces Firefox to show the certificate warning. We can see that we get a warning message about an untrusted certificate. Let's click I understand the risks, add exception. Now click Get Certificate and then View. In this new window, we can see all the details of the certificate. In order to download it, let's move in the tab Details. Select the root certificate and click Export to save the certificate to our local machine. Now that we have the certificate stored on the machine, let's use the Python script to install it on the simulator. So let's open a new terminal, then move to the folder where the Python script is stored and run the command. Python iOS cert trust manager.py -a. Then we'll put the name of the certificate, which is Portswigger CA. As we can see, the tool asks if we want to add the certificate. Let's enter Y and continue. So it seems that the certificate has been installed on the simulator. If everything works fine, we should now be able to load HTTPS pages without receiving any warning. So let's go back into Burp and enable the intercept option. Now from the device, let's try to load the address https://www.google.com. As we can see, the request is intercepted, and if we forward it, there is no warning message on the device, meaning that the proxy through SSL is now working fine. We can navigate every site through HTTPS at this point. For example, let's set the interception option to off. Then move in the History tab and delete all the items. Now if we open any other HTTPS site, such as Twitter, we can see that Burp intercepts the clear text of the traffic, and we can analyze all the requests and the responses from these sites. Note that the proxy works for installed applications as well. Here, for example, let's open Maps. As we can see, all the traffic has been intercepted, both HTTP and HTTPS traffic. So now that we know how to set up the simulator, let's see how to configure an actual device. In the second part of this video, we're going to use Charles Proxy, but the same operations and steps can be performed from both proxies. So let's close Burp and start Charles. While Charles loads, let's open VNC and see how to set the proxy configuration on the actual device. In this case, we are sharing the same Wi-Fi network with the proxy server. Let's open Settings, Wi-Fi, then click on the blue arrow on the right of the Wi-Fi we are attached to, and then at the bottom of this view we can see the HTTP proxy configurations. Before editing, let's go back in Charles and configure the proxy settings. Here we can tell Charles to use the configuration set on the machine, so we don't need to configure anything else. Let's go back into the device and configure the proxy settings there. Let's change the HTTP proxy option from auto to manual and start configuring the address and the port of our proxy server, where the address will be 192.168.3.26 and the port will be port 8080. Now that the proxy settings have been set, let's clear all the traffic intercepted and verify that this works. Let's open Safari and let the device load the home page, which is elearnsecurity.com. As we can see, as soon as it sends the request, Charles was able to intercept it. So the proxy is working fine, and we can see all the requests and the responses are intercepted. Let's verify if the configuration works for applications as well. Let's open iBooks. As we can see, some of the traffic is sent through HTTPS and some through SSL. The traffic that goes through HTTP is in clear text. Here we can see the requests and responses. While if we open the HTTPS node, we can see that something went wrong and we can't even inspect the responses. This happens with other applications as well. If we start Evernote, we can see an alert that warns about an invalid certificate. So let's click OK and check the traffic in Charles. Here again, we can see that some data has not been intercepted since the application works through SSL. So right now we cannot successfully intercept the traffic that goes through SSL, but we already know that we won't be able to get unencrypted data until we install the root CA certificate. While for the simulator, we had to use a Python script to add it to the database. On actual devices, we can just open the certificate and let the OS install it. If we have a custom certificate, we can do it a few different ways. We can send the file through email, use applications such as Dropbox, upload the file on a website, and then browse it from Safari. Charles already has the root CA certificate online, so if we want to install it, we just need to open the following address from Safari: http charlesproxy.com/charles.crt. Once we open it, we can see that iOS asks us if we want to install the certificate on the device. Let's install it and then go back to Charles. We need to edit the Charles proxy settings in order to instruct the tool to intercept all the SSL traffic. To do this, let's click on Proxy, Proxy Settings, then open the tab SSL. Now make sure that the checkbox Enable SSL Proxying is enabled. Let's delete all the entries in the location pane, and let's add a new one by clicking the Add button. Here let's insert a start character in the host field. This instructs the tool to intercept SSL traffic for every host. As a final step, let's confirm our changes and restart Charles. Right now, the root CA certificate has been installed. We can try to load the address https://google.com once again. Once it's entered, we can see there is no warning, and we can also inspect the clear text in Charles. Every request and response is now readable where it wasn't before. This configuration works for applications as well. Again, if we try to open Evernote, we can see that the application successfully synchronizes the notes, and we can see the intercepted traffic within Charles. To prove that Evernote works, let's edit a note and then verify what Charles was able to intercept when we confirm the edits. So the note has been updated, and now Charles can see the requests that were sent. Here we can see update note, and a few lines after, we can see the text added. So in this video, we have seen how to configure both the simulator and an actual device to work with two different proxies, Burp Suite and Charles. We have also seen which configurations are needed to intercept SSL traffic. Note that almost all the steps seen in this video can be performed on machines with different OSs. We advise that you set up your environment and analyze data transmitted by different applications. This will help you to understand how they work, as well as if any sensitive data is passed through any unsecure connections. Thanks for joining us.